Guys, hello everyone. I'm back with my next lesson. So today we have 8-3 and still we are doing integral of log functions. Okay, so I showed you a few examples yesterday, and remember I said, okay, if the top expression, the degree of the top is less than the bottom one, so that's where we do 1 over and we do natural log functions for those. But today's example is slightly different. So look at this one here. I have x squared plus x plus 1 over x squared plus 1. What I see is the degree for top and bottom expression is square, so it means it's the same. If I look at the derivative of the bottom one, it's no way going to be same as this one. So it means finding or rewriting as 1 over, it would not work for this one. Or I cannot split up into multiple fractions either, because the bottom expression is not just one expression or one piece. If it's just one, yeah, we can split up, but we have multiple pieces in the denominator, so you can't do that either. So you have to find a different way to do it. This is where I'm going to think about rewriting this. So we need to rewrite this problem. When I say rewrite, I'm trying to say in terms of, let's say, pretend you have a fraction like this. If I ask you to rewrite this fraction, isn't it I can write in a mixed number? I can write it as, wait a second, gosh, whew, now better. I can rewrite this as this, because I know 4 times 5 makes 20, added to 1, it makes 21 over 5, which is same as the first one. So basically, this is the same approach I'll be using for this function. So I'm going to rewrite this expression into a mixed fraction. How do we rewrite? So for that, you need to divide this function. And we have to do long division because remember the divisor is bigger than 1. So if divisor is higher than 1, you have to do long division. So let's divide this function. I have x squared plus x plus 1, and I have x squared plus 1 outside. So in order to divide, we compare first terms. X squared times what makes x squared? It's 1. So I would multiply by x squared. So it's x squared times 1 times 1, because it's x squared plus 1 times about 1, so plus 1 here. Then we subtract, so we switch signs. This becomes negative, negative, these two cancel out, so I have x and 1's going to get canceled out too. So this big expression or big fraction can be rewritten as 1, which is the quotient, plus remainder, which is x over x squared plus 1. Here you go. Basically, it's the same equation I started off with, but I rewrote it. So now once it's rewritten like this, you just have to integrate every single piece. So integral of just a constant, you just have to add x to that. So this would be x. So integral of this piece. Now the top one is less than the bottom one. So it means this is going to be log function. So you could rewrite this first. Let's rewrite this as this. So what I see is I see 1 over something, but I need to check if the other piece, derivative of this or not. Derivative of x squared plus 1 has to be 2x. So it means a 2 is missing. So this is where I need to bring in the number. So this 2 and this x would complete the pattern. So I already have this x outside. I would factor out 1/2. And the integral of this whole piece would be ln of x squared plus 1, and I would add c at the end. So I repeat, so anytime the top degree and the bottom degree is the same or top is bigger than the bottom one, so always think about rewriting the function first, and once you have everything rewritten, then just take integral of every single piece. So let me show you one more. Let's say I have something like, let me use a different color. It's kind of fun playing with these colors. Okay, so now I have 2x over x plus 1, and there's a square in dx. I do see the top degree is less than the bottom one. It's less because once I distribute the square, this x would become x squared. So that's the reason I'm saying the top is less than the bottom one. But the top expression doesn't seem to be the derivative of this inside part. So for something like this, I would recommend you doing U-sub. Okay, when it comes to U-sub, so now the question is what part needs to be equal to U? So keep in mind, always take the denominator expression and set it equal to U. That's the easiest way you can tell. Or you can just look at the highest exponent and set it equal to U. So I know x plus 1 square, it has the highest degree on the top and it's in the denominator, it's in parentheses. I would set x plus 1 equal to U. Okay, now I hope you remember it's always easier to actually have all those things handy at the first place. I'm just going to do the derivative and I'm going to solve for x because later on I might need that information, so it's easier if you have it handy. I would do derivative of this first. This would be 1. Let's just solve for du. So I would do cross product, so du is equal to dx. That's one of the equations I might need for my U substitution process. There's another thing you might need. It could be the x value. So let's just take this equation and solve for x. So I know x would be equal to u minus 1. All right, so far I have these two different equations I may use for this U substitution. Back to this. Now time to replace everything in terms of u. So I already see 2. Oh, x. X can be replaced with u minus 1. And I already know x plus 1, it's already equal to u, and there's a square. And dx is equal to du. All right, so I have everything, pretty much every single thing in terms of u. Now rest is pretty much integral of this function. Just to make it easier, I'll factor out the constant. So this equation looks something like this. And I hope you remember anytime it's one big fraction, it's easier if you split up. So I'll keep this 2 outside. And I'm just going to put bracket because later on once I split up into pieces, there are going to be multiple pieces here. So I would do u over u square. There's still integral. I have 1 over u squared, still there's integral, and I'm just going to put bracket. Again, why bracket? Because this 2 would go with the entire thing. Now let's try simplifying. So if I simplify the first one, I have 1 over u left. Second one, there's nothing you could do, but I can take it to the top. Okay, now, this one, the first one, how come I don't want to take this one to the top? Now, the reason I would not take it to the top, because if I take it to the top, then if I add 1 and then divide, isn't it that would make it undefined? So the first piece definitely going to be a log function. So let's simplify. And is it anything that's missing? Any number? So derivative of u is 1, so there's nothing missing. So I would just do, it's ln of u, because 1 over this function and it already has its derivative, so it's ln of u. I'm just going to put absolute value. Second one, it's not ln. Why? Because if I add 1 and if I divide by the same thing, it doesn't make this fraction undefined. So that's just normal integral. So this would become u to negative 1 over negative 1. Let's simplify more. So I have 2 ln of u. This one simplify, I would say negative and negative would become positive, and I would move this u to the bottom, and this is what I have. And the last step is bringing back the original equation, and we know u is equal to x plus 1. So my final answer would be, if you want to distribute this 2, you could do that. I'm just going to leave it outside. So it's ln of x plus 1 plus 1 over x plus 1, and at the end there's a c. Here you go. And yeah, this is pretty much all. So if you need help on any of these steps or any of the questions on your homework assignment, just send me a comment. I'll answer that. All right, thank you guys. Thank you very much. Thank you for watching. Bye-bye.